All right, before we start this lesson, work on this warm-up problem. Take about 5 to 8 minutes, work independently, and then you will be called to the board, either volunteer basis or random, depending on what y'all need. And then your answers will be checked together, and then we'll move on to the lesson. So pause the video, take about 5 to 8 minutes on this warm-up. All right, now that you are back and you have checked your warm-up answers, we're going to move on to 9.1. So go to page 783 in your books, and we're starting with the Explore It problem. So work independently on the Explore It problem, just A and B, for about 5 minutes. And once 5 minutes has passed, turn and talk to the person next to you. See what you found for both A and B. So pause this video, work on the Explore It. All right, so you should have worked on this problem and then talk to your partner about it. Hopefully what you noticed, for part A, we're looking at each pattern, figuring out what's going on each time, and then figuring out what would come next. So in the first pattern, we kind of noticed that each time we're adding a row. So we always have 2 columns, but then we're adding a row. So in the next, if I can draw it, in the next one for part 1, you would have 2 columns, but now there would be 6 rows. So you would have 12 tennis balls in the next one. In part 2, you might have noticed that it's square numbers. It makes a square every time. You've got a 1, a 2 by 2, a 3 by 3, a 4 by 4. Or you may have just noticed they're adding a row and a column each time. So either way, you should have gotten that in the 5th figure, you would have 25 water bottles. And then finally, in the last problem, what you probably noticed is that they are adding a row, and then they're also adding 2 columns. So if I did that to this figure, then in my 4th image, I would have 36 helmets. Now looking at part A, if we want to, or looking at part B from part A, if we want to find the number of objects in the 10th figure, the thing we're going to think is I want to make an equation. So in the first figure, the tennis balls, if I'm multiplying, or I'm adding 2 every time, it's like I'm multiplying each position by 2. So I've got that in part 1, all right, part 1, I'm taking 2 times x. So in the 10th row, or 10th position, I'm going to have 2 times 10, which equals 20. If I can type on this tiny keyboard. All right, in part 2, so I noticed that I have square numbers, which means I have each position squared. So in the 10th position, I've got 10 squared. which equals 100. And then finally, in the third image, it's a little more difficult to see. But the equation that I came up with for this is that I have x times 2x plus 1. And so if I plug in 10 for that, I have 10 times 2 times 10 plus 1, which would then equal 10 times 21, which is 210. And it's okay if you didn't quite get that equation, but you hopefully noticed the other two at least. All right, so moving forward, let's actually talk about what we did just then. So we're working with sequences. You should have learned about sequences a little bit in Algebra 1. A sequence is an ordered list of numbers. Each number in a sequence is called a term. Each term, so we label each term a sub n. The n comes from the position in the sequence. So a sub n is in the nth position. So if I'm looking at this sequence here, the first position is the term 5, which means that 5 is the term a sub 1. 15 is pointed out, that's in your third position, so 15 is the term a sub 3. So the relative positions of the terms make up the domain of a sequence. So 1, 2, 3, 4, 5, 6, 7, those are your positions. The terms themselves make up the range. So in the sequence example there, your range would be 5, 10, 15, 20, 25, and so on. Now, a sequence can be specified by an equation or a rule, which is what we were doing in the Explore It. We were finding the equation or the rule for that sequence. Now, the domain could begin with 0 instead of 1, but if they don't say that, just assume it starts with 1. So you could technically find the 0th term if you needed to. All right, so example 1, writing the first 6 terms of a sequence. We've got the sequence a sub n equals 2n plus 5. If I want to find the first term, I'm trying to find a sub 1, which means I'm replacing n with 1. So 2 times 1 plus 5, which that equals 2 plus 5, which is 7. So my first term is 7. A sub 2, I'm finding the second term. 2 times 2 plus 5. So that's 4 plus 5, which is 9. A sub 3, we have 2 times 3 plus 5. 6 plus 5 is 11. A sub 4, we have 2 times 4 plus 5. That's 8 plus 5, which is 13. A sub 5, 2 times 5 plus 5, that's 10 plus 5, which is 15. And then a sub 6 is 2 times 6 plus 5. So 12 plus 5 is 17. So these are the first 6 terms of our sequence: 7, 9, 11, 13, 15, 17. All right, example 2. So we've got another sequence, a sub n equals negative 3 to the n minus 1. Again, we're just finding the first 6 terms. So a sub 1. Oops. A sub 1, when I plug in 1, that's negative 3 to the 1 minus 1. So that's negative 3 to the 0 power. Anything to the 0 power is 1. A sub 2 is negative 3 to the 2 minus 1. So negative 3 to the first power. Anything to the first power is itself. A sub 3 is negative 3 to the 3 minus 1. So negative 3 squared. Remember, if it's squared, that negative times negative becomes positive, so that's positive 9. A sub 4 is negative 3 to the 4 minus 1, so negative 3 cubed. Negative 3 times 3 is 9. 9 times negative 3 is negative 27. A sub 5 is negative 3 to the 5 minus 1, so negative 3 to the 4th power. So negative 3 times negative 3 is positive 9. 9 times negative 3 is negative 27. Negative 27 times negative 3 is positive 81. And then finally, oh my goodness. If you need to go back to the video and pause for a second so you can copy those first 5 terms, go ahead and pause and go back. But our last term, a sub 6, negative 3 to the 6 minus 1, so negative 3 to the 5th power. So we're taking 81 times negative 3, that's negative 243. So our first 6 terms are 1, negative 3, 9, negative 27, 81, and negative 243. All right, so for the self-assessment problems, they give you the rules for 3 sequences, and then you're going to find the first 6 terms. For number 4, it's very open-ended. If you get to that point, try it. But you will have to check your own work and make sure it works. So you will have to check whatever you get and make sure that it matches what it's asking for. So self-assessment, take about 6 minutes and then unpause and check your answers. All right, so you should have worked independently on the self-assessment problem. For number 1, a sub n equals n plus 4, your first 6 terms should have been 5, 6, 7, 8, 9, 10. Number 2, your first 6 terms should have been 1, negative 2, 4, negative 8, 16, and negative 32. And then finally, number 3, your answer should have been 1/2, 2/3, 3/4, 4/5, 5/6, and 6/7. Number 4, your answers would vary. Check your answers, and if you have any questions, go ahead, raise your hand, pause the video, and ask any questions you have. Or check with the person next to you, make sure you both understand. Okay, moving forward. Graphing and writing rules for sequences. So first thing is graphing. If you're graphing a sequence, we already said the position in is the domain. So those are your x values. The terms, a sub n, are your range or your y value. So you'll plot the ordered pairs in a sub n. So looking at example 2, I'm just going to write this on here first. My sequence, I'm going to make a table for n and a sub n. N is just your position. So in my first position, I have the term 1/2. Second position, I have the term 2. Third position, I have the term 9/2. And then fourth position, I have the term 8. So when I'm plotting these points, my x value is my n, my y value is my a sub n. So I have the point 1, 1/2. Then my second point is at 2, 2. My third point is at 9/2, which we can think of as 4.5. It might make it easier to graph. So 3, 4.5. And then my fourth term is 4, 8. Notice the graph of a sequence is discrete, not continuous. Only plot the terms. So n, a sub n. Don't connect. Your dots. So this is not going to make a continuous graph. I'm not going to connect any of my dots. I'm just plotting the dots because those are the only things in my sequence. I don't want the things in between. All right, example 3. So now we've graphed one. Now we're going to see if we can write a rule for a sequence. So for part A, I've got the terms -1, -8, -27, -64. For right now, you were just trying to find something that works. In 9.2 and 9.3, we will be given more specific ways to find the rules. But for right now, you're just trying to find something that works. So what I'm noticing about this, first of all, I notice they're all negative. And then if I think about this, -1, that's the same thing as -1 to the third power. -8, that's like I'm taking -2 to the third power. -27 is like I'm taking -3 to the third power. And -64 is like I'm taking -4 to the third power. So what that means is that if I want to find the fifth term, the next term, then I'm taking -5 to the third power, which -5 times -5 is +25, times -5 is -125. If I want to write a rule for this to find any term, a sub n, then I'm just taking -n to the third power. Whatever position it's in is negative that to the third power. All right, part B, 0, 2, 6, 12. So I notice I start with 0, and then I'm going up 2, and then I'm going up to 6. It's like I'm taking each previous term and I'm multiplying it by the position it's in. So if my first term is 0, it's like I'm taking the position 1 and multiplying it by the previous position, which would be 0. My second term, I'm taking the position, multiplying it by the previous position, 1. Third term, taking the third position, multiplying it by the previous position, 2. And then fourth term, multiplying that by the previous position, 3. So a sub 5, I'm taking 5 and multiplying it by the previous position, 4. So the fifth term would be 20. The way I'm going to write that, a sub n, if I'm multiplying each position, that's n, times previous position, well, what comes before n? N minus 1. Sorry, guys. All right, self-assessment. Skip 8. Do not worry about 8. Take no more than 10 minutes, pause the video, work on the self-assessment independently, and then come back to check your answers. All right, so you should have come back now. You should have paused, worked independently. Number 5, I have 3, 5, 7, 9. I'm noticing that each time it's like I have 2 times the position plus 1. 2 times the position plus 1. Every single time. So if I want to find the next term, I'm going to take 2 times 5 plus 1. So the 5th term will be 11. To graph the first 5 terms, so I'm going to make my table in A sub n. So my first term is 3, second term is 5, third term is 7, fourth term is 9, fifth term is 11. So I'm plotting these points. All right, so point 1, 3, 2, 5, 3, 7, 4, 9, and then 5, 11. And then to write a rule, so A sub n, my nth term, I'm taking 2 times the position it's in plus 1. All right. Number 6. You should have noticed that you have, it's like you're taking -2 to the power, the position minus 1. So -2 to the 1 minus 1, -2 to the 2 minus 1, and so on. And so if I want to find the 5th term, I'm taking -2 to the 5 minus 1, which is -2 to the 4th power. So -2 times -2 is +4, times -2 is -8, times -2 is +16. So my 5th term is 16. So when I graph this, I have first term is 1, second term is -2, third term is 4, fourth term is -8, and 5th term is 16. Sorry, this looks a little janky. All right, so we have 1, 1, 2, -2, 3, 4, 4, -8, and then I can't fit it on here, but 5, 16 would be like up here. All right, last one to check, number 7. 2, 5, 10, 17. So I would notice with this one, I'm taking the position, squaring it, and adding 1. Position, squaring it, adding 1. Each time I'm taking the position the term is in, and I'm squaring it and adding 1. So for the 5th position, I'm going to find 5 squared plus 1. 5 squared plus 1, 25 plus 1, it's 26. All right, so to graph it, our first 5 terms are 2, 5, 10, 17, and 26. We'll see what I can fit on here. Okay, I can get at least to 17. So my first point is at 1, 2. Second point is at 2, 5. Third point is at 3, 10. And then fourth point is at 4, 17. And then the fifth point would be all the way at 5, 26. And so my rule for this, a sub n, I'm taking the position, squaring it, adding 1. So n squared plus 1. All right, moving on to our last example, we've got the modeling real life example. So you work in a grocery store and stack apples in the shape of a square pyramid with 7 layers. So look in your picture in your book. You've got this pyramid. The first layer is your 1 apple. And then each time you go down, you have a square. So write a rule for the number of apples in each layer. To write a rule, I'm going to make a table. So in each layer, number of apples. So on my first layer, I have 1 apple. In my second layer, I have a 2 by 2 square, so I have 2 squared, which is 4. Third layer, I have a 3 by 3 square, so that's 9. Fourth layer is 4 by 4, 16. So we can see where this is kind of going. Our rule is going to be a sub n equals n squared. So to graph our sequence, we've got our table already ready. We have the point 1, 1, 2, 4, 3, 9, and then you would keep going up higher and higher. B, you want to restack the apples in the same shape but with 9 layers. How many additional apples do you need? So my stack already has 7 layers. So I just need to add layer 8 and layer 9. So to find layer 8, I'm going to take 8 squared. That's 64. To find layer 9, I'm going to take 9 squared. It's 81. And then to find the total that I'm going to need to add, I'm just adding 64 plus 81, which I would get that I need 145 more apples. All right, if time permits, work on this self-assessment problem. Don't worry about B, so just worry about A. Pause the video, take no more than 10 minutes, and then we'll check it together. All right, you should have paused, come back, checking our answers. If we have this pyramid of pennies, and each layer consists of n square stacks of 11 pennies each, that means that we have 11 times n squared in each layer. So our rule is a sub n equals 11n squared. Go ahead, since it says graph the sequence using technology, practice graphing this in your calculator. So go to y equals and type 11n squared and then graph it. And now what your graph is going to do is it's going to create a continuous graph, but we know that it's just each whole number. So if we think about it, the first layer will have 11 pennies. The second layer will have 2 squared, which is 4 times 11, so it'll have 44 pennies. Third layer would have 3 squared, 9 times 11 would be 99 pennies. So all of these points would be your points on your graph. Okay, now your homework for this section, page 789 to 791, numbers 2 through 6 evens, 12 through 16 evens, 24 through 26, and 28. Make note of your due date. Your homework quiz will be on the same day as your test. We will not have a separate review day. Your review day will be after your 9.4 lesson. So make sure that you are prepared for both your homework quiz and your test on the same day. Check your answers on your homework using the key on Google Classroom.